Today's class will be on the peritoneum. Peritoneum is a fold of tissue which holds the intestine and the abdominal organs in the abdominal cavity. The peritoneum is a it is a four-layered membrane in development. So it is basically made up of four different types of layers, and they are fused. They are fused to form an outer parietal and an inner visceral layer of peritoneum. So in between these two layers, outer parietal and the inner visceral layer, there exists a potential space. What do I mean by potential space? Potential space means it is a space filled with fluid or water, watery like secretion. So that is called as a peritoneal fluid. The peritoneal fluid is a place where there is lubrication and it contains macrophages for the protection of the organs within the abdominal cavity. So the absolute function of peritoneum is protection, and its movement, it helps in the providing cells for defense within the abdominal cavity. So see the next slide. This is the location where the abdominal viscera are located, and they are located below the rib cage. So they are located well below the liver, the stomach, the intestines. And see, they are all sacked together in a closed double layered peritoneal sac, what we call it as the peritoneal sac. This peritoneal sac is being divided into compartments anatomically. Now we will talk about everything in detail. Now see the location of the organs within the abdomen. So it is closely packed by a double layered membrane called as the peritoneum. The peritoneal cavity we will study it under three headings: the peritoneum, the peritoneal cavity, structures formed by the peritoneum. The peritoneum is basically two layered: the parietal peritoneum and the visceral peritoneum. So this is a cross section of the abdomen where the liver, this is the stomach, and this is the pancreas on cross section, the duodenum, and the location of the transverse colon. These are the coils of jejunum and ileum placed within the intestine, the peritoneal sac. So on the cross section, we will be able to see the abdominal organs like this. Around these abdominal organs, an orange colored lining that has been shown is the layers of peritoneum. This is the urinary bladder, and this opening, what you see, will be the terminal end of the rectum and the anal canal. The peritoneal cavity is a potential space formed by the parietal and the visceral peritoneum, containing a thin film of serum-like fluid called as the peritoneal fluid. It is a closed sac in male, while it is an open sac in female. Why do we call it open sac? Because in female, because of the opening of the uterine fallopian tubes towards the uterus, and it is connected with the ovarian mesosalpinx. So there the fallopian tube becomes open to the peritoneal cavity, and the passage of the passage becomes patent or open in female, while in males it is a closed sac. So the intraperitoneal organs, we classify the location of the organs into three types based on its location. If it is located within the peritoneum, it's called intraperitoneal organs. If it is present within the compartments, but within the compartments, it is the intraperitoneal organs. Say the peritoneal cavity, it will be divided into number of compartments. Okay, so it will be divided into supracholic compartment and intracholic compartment. So the organs which are located within the supracholic and the intracholic, we call it as the intraperitoneal organs, where you get the organs to be located in different positions within the same sac. Then extraperitoneal means the organs which are located behind the peritoneal cavity are called as the extraperitoneal organs. These, if you see this image, in this image you will be able to see the omentum, the stomach, the liver, the viscera, the spleen, and the kidney in cross section. And there is a double layered viscera there. See, this is the visceral peritoneum, and this is the parietal peritoneum. So if we see it as a cross section, the peritoneum connects the organs. It is covering the organs like a sac, and it is getting attached to the posterior abdominal wall. So the covering of the peritoneum that is seen around the organ is called as a visceral peritoneum. It is connected by the parietal peritoneum, and by the means of something called mesentery, and it is getting attached to the posterior abdominal wall. That is how it is arranged. So this is the different types of omenta that is seen within the peritoneum. So if we take the peritoneal cavity has omenta which can be divided into the lesser omentum, the greater omentum, the omental bursa, epiploic foramen or omental foramen, and the ligaments that we see will be double layered peritoneum, mesenteries of small intestine, the transverse colon and the sigmoid colon. So this is the peritoneum that has the which we during the developmental phase, the entire GI system develops itself into three different parts: the foregut, the midgut, and the hindgut. So the foregut is something that is located, which is supplied by the colic artery, isn't it? I'm sorry. The foregut is something which is supplied by the celiac artery, and the midgut which is supplied by the superior mesenteric artery, and the hindgut which is supplied by the inferior mesenteric artery. So the celiac artery becomes the principal artery for the foregut, and when it is placed in the fetus, it is held together by the means of a thick tissue called as the mesogastrium. Mesogastrium is nothing but the future of peritoneum. This mesogastrium only later develops into the peritoneal foldings, and it can be divided into the ventral mesogastrium and the dorsal mesogastrium. So the ventral mesogastrium and the dorsal mesogastrium becomes a future peritoneum which holds the organs in position. And during the developmental phase, they undergo rotation. The gut itself undergoes rotation, because of which some of the organs go retroperitoneal. For example, the pancreas, the spleen. So these organs go retroperitoneal because of the rotation of the gut. So this is the development image of the peritoneum. This tissue which you see within the intestine is called as mesogastrium. So this is again a cross section where if you see, this is the outer abdominal wall and this is the organ that you see. Say suppose it's an intestine. The intestine is getting from the mesentery or the outer peritoneum that connects the intestines to the posterior abdominal wall is called as a mesentery, and this is the thoracic or the lumbar vertebra, posterior body wall structures to which it is getting connected. So this is in cross sectional view. Let's go into the lesser omentum. The lesser omentum is a bilayered structure, and it's a fold of peritoneum which extends from the lesser curvature of the stomach. The first 2 centimeters, it extends up till the first 2 centimeters of the duodenum and to the liver. The greater and the lesser sacs will communicate through the small foramen that is present between the greater sac and the lesser sac, called as the epiploic foramen. See, this is the lesser curvature of the stomach. The peritoneum that is stretching out from the lesser curvature of the stomach to the inferior surface of the liver is called as the lesser omentum, while the peritoneum that is extended towards the greater curvature of the stomach, extended towards downward, is called towards the completely covering the entire coils of intestine, is called as the greater omentum. The lesser sac is a sac which is present within this omentum, and the greater sac is the space which is present within the greater omentum. So the lesser omentum, it is not only a thin fold of peritoneum but also becomes the content which holds many structures. What are all the structures which it holds? The hepatic artery proper that supplies the liver, portal vein, bile duct, lymph nodes and lymphatics of the liver, hepatic plexus of nerves enclosed in perivascular fibrous sheath, right gastric vessels, left gastric vessels, and the gastric group of lymph nodes and lymphatics. Branches of the gastric nerves that supply the stomach also become the content of the lesser omentum. So, next coming to the location, see here, this is the lesser omentum, which is, you can see a translucent material that connects the lesser curvature of the stomach with the liver. So this becomes the lesser omentum, and this is the gallbladder to which it is attached. The porta hepatis is nothing but a structure that is seen in the lower or the inferior surface of the liver, which contains the hepatic artery, portal vein, and the bile duct, and the the attachments to which it is getting attached is from the lesser curvature towards the porta hepatis, which is present in the inferior surface of the liver, and also to the proximal part. Proximal means the first 2 centimeters of the duodenum also gets attached to the lesser omentum. Other than that, there are also 2 ligaments that you find here, the hepatogastric ligament and the hepatoduodenal ligament. Hepatogastric means the ligament that attaches the liver to the stomach is called as the hepatogastric. The ligament that attaches the liver to the duodenum is called as the hepatoduodenal ligaments. Coming to the greater omentum, the greater omentum is 4 folds of peritoneum from the greater curvature of the stomach, descending, covering the descending colon, transverse colon, covering the small intestine completely. So this is the greater curvature of the stomach. From here extends the greater omentum. See, the greater omentum is fully filled with fat and it contains blood vessels as well. This is called as the a shield for the entire abdominal cavity. So it's an army guard for the entire abdominal cavity. So it's going to cover the coils of small intestine. The greater omentum is a 4-layered membrane or a 4-layered ligament which covers the entire coils of intestine. So how will it look like when it is taken as a cross section? On a cross section, you can find the peritoneum covering the stomach. Then the presence of the peritoneum also covers the organs which are present within it, and it also forms a potential space within the greater omentum, what we call it as a greater sac. So this greater sac becomes a space for filling of fat and it contains lot of blood vessels. So what is the main function of the greater omentum? The greater omentum mainly is a storehouse of fat. It is a protective covering for the entire peritoneal cavity against the infections. It is a membrane that is going to lodge in a lot of macrophages and it will prevent the spread of infection from one side of the abdomen to the other side. It is also called as the policeman of the abdomen because it lodges a lot of macrophages and defensive cells. Coming to the omental bursa. So, what is an omental bursa? This is a recess. See here, this is the recess that is seen. Recess means space. The space that is seen below the diaphragm. And this area is called as the superior omental bursa. So, within the omentum, you also find some spaces called as the omental bursas or the recesses. So on the left side, on the left part of the stomach or left quadrant, you find the spleen, the gastrosplenic ligament and the splenorenal ligament getting attached to the left quadrant. Spleen, it is mainly attaching the greater omentum gets itself attached to the spleen, forming the gastrosplenic and the splenorenal ligament. Splenorenal means from the spleen to the kidney. So the left border of the omental bursa, that is the lesser sac, will be the organs like spleen, gastrosplenic ligament and the splenorenal ligament. So this is a cross section in which this is the stomach and the this is the porta hepatis of the liver, which is seen inferior to in the inferior surface of the liver, and this is the hepatogastric ligament on cross section. So a ligament that connects the stomach and the porta hepatis of the liver is called as the hepatogastric ligament, and this is the spleen which is seen on the left corner. This is the omental foramen. Omental foramen is the foramen which gives entry to the sac, the lesser sac here. And here you also find the other viscera like the left kidney, right kidney and the abdominal aorta IVC on the cross section. So this is again an image that shows the right border of the omental foramen, where the anterior on the right side what you get will be the liver. Left side it is the spleen, right side it is the liver. So anterior hepatoduodenal ligament, posteriorly you get the peritoneum covering the IVC, superiorly you get the caudate lobe of the liver, and inferiorly it is the superior part of the duodenum. So the space that is seen between the liver, the stomach and the duodenum becomes the right border of the omental foramen. So anteriorly it is the hepatoduodenal ligament, posteriorly it is the peritoneum covering the IVC, the superiorly caudate lobe of the liver and inferiorly it is the superior part of the duodenum. So the clinical importance of the omental foramen, so it's a way of communication between both the sacs, the greater sac and the lesser sac. And here it is also helpful for ligation of the vessels. It is helpful for the approach. It is also useful for the approach and mainly for the ligation of the vessels during surgery. So, so this is the superior recess of the omental bursa, where you will be able to see the superior recess here on reflection of the liver that's in front of the IVC. So this is a hepatorenal recess again. So the recess that is present within the lesser sac between the liver and the kidney. Behind the liver on the right side, the space between the liver, right lobe of the liver and the right kidney, we call it as a hepatorenal recess. It's again a small space that is seen within the peritoneum. So coming to the mesentery. What is a mesentery? The mesentery is nothing but a fold of peritoneum that lodges the coils of intestines and attaches the intestine to the posterior abdominal wall. So the purpose of the mesentery is, it is a broad fan-shaped peritoneum which suspends the coils of jejunum and ileum, and it attaches these coils of intestine to the posterior abdominal wall. So the root of mesentery, root means the place where it is getting attached to the posterior abdominal wall, is around 15 centimeters, and it is directed towards the right of the posterior abdominal wall, and it will be from the duodenojejunal flexure on the left side. It extends from the duodenojejunal flexure on the left side, corresponding to the level of L2 vertebra, up till the upper part of the right sacroiliac joint. Right sacroiliac joint. So the borders of the mesentery can be of two types. One is the attached border, another is the free border. The attached border is the border which is attached to the posterior abdominal wall, and the free border is a border which is 6 meters long, and it is thrown into foldings or pleats which attaches the gut to the visceral peritoneum and forms a serous core. The main function of mesentery is to attach the coils of intestine to the posterior abdominal wall, first thing. Second, it also has the jejunal and the ileal branches of the superior mesenteric artery. It has the accompanying veins, that is the jejunal and the superior mesenteric veins also accompany it. The autonomic nerve plexus, the lymphatics, lacteals, 10 to 100 to 200 lymphatic channels or lymph nodes are present within this mesentery. So it is also becoming a place to lodge the lymphatics. It also has a thick bed of fat. So the mesentery is a place to lodge the fat, lymphatics, blood vessels, nerves, veins. This is an image that shows you the peritoneal ligament that is attaching to the liver. What are all the peritoneal ligaments that attach the liver? So the peritoneum basically, it can be divided into, first peritoneal, the omenta. The peritoneum can be given a name omentum, the lesser omentum and the greater omentum. The lesser omentum will form they form a sac called as a lesser sac, and the greater omentum forms the greater sac. The mesentery is a folding of peritoneum that holds the coils of intestines to the posterior abdominal wall, and that holding the portion of the peritoneum that holds the coils of intestine is called as the mesentery. Now, another variety of the peritoneum itself, the peritoneum will convert itself into peritoneal ligaments, helping it to connect one organ to another organ. That is called as the peritoneal ligaments. Example is the hepatoduodenal ligament, hepatogastric ligament, hepatorenal ligament, coronary ligaments, falciform ligament, ligamentum teres and the right and left triangular ligaments. So these are the ligaments that connects two organs within the peritoneal cavity. So the peritoneum is not only meant for forming omentums and sacs, but it also interconnects the organs that are present within the peritoneal cavity. For example, hepatoduodenal means it is connecting the liver to the duodenum. Hepatogastric from liver to stomach. From hepatorenal from liver to the kidney. Coronary ligaments, then again it is present on the liver on the superior surface. The falciform ligament, the coronary ligament attaches itself to the diaphragm, and the triangular ligaments also present onto the surface, superior surface of the liver. So similarly, the ligaments which are attaching itself to the spleen, gastrosplenic, splenorenal, iorenal, splenocolic. What do we mean by that? Gastrosplenic means from spleen to stomach. If it connects, the ligament is called as the gastrosplenic ligament. See, this is the spleen and this is the stomach. So a ligament that connects both this is called as the gastrosplenic. Then from the spleen to the kidney, it is the splenorenal. Then from the spleen to the diaphragm above, splenophrenic. And splenocolic means from the spleen to the coils of intestine that is seen below, that is the splenocolic ligaments. So ligaments which attach itself to the stomach are the hepatogastric, gastrosplenic and gastrocolic. The ligament that connects the stomach with the liver is called as the gastrosplenic. Hepatogastric. The ligament that attaches the stomach to the spleen that is seen behind, the purplish structure that is seen behind is called as the spleen. And the ligament that connects it is called as the gastrosplenic. The ligament that connects the stomach with the transverse colon or the intestine is called as the gastrocolic. So these are the ligaments that connects it. So the mesenteries which we spoke about just now has been given a diagram. So this is the coils of mesentery that is lodging. If you find this is the posterior abdominal wall, after removal of all the intestine, small and large intestine and its coils, you can find the posterior abdominal wall containing the kidneys, the coils of the mesentery, and this is the pancreas and IVC. This is the C-shaped second part of the duodenum. This area is called as the root of the mesentery. So when I spoke about the mesentery, let me repeat it once more. The mesentery is a proper broad fan-shaped attachment of the peritoneum that suspends the coils of intestine from the posterior abdominal wall. It has two borders. One is an attached border, another is a free border. The root of the mesentery will be around 15 centimeters in its length, and it's extending from the left side, that is the duodenojejunal flexure, from the duodenojejunal flexure area up till the right sacroiliac joint. So this becomes the extension of the root of the mesentery. So this is a point from where the peritoneal folds cover the intestine and gets itself attached to the posterior abdominal wall. This there are two borders I said. One is the attached border and another is a free border. The free border or the intestinal border we call it because it covers the intestine and it is free. It's around 6 meters in its length and it is thrown into a number of foldings in which there is presence or attachment of the intestines. So the mesentery contains the jejunal with ileal vessels of superior mesenteric artery, their accompanying veins, autonomic nerve plexus, lymphatics, 10 to 100 groups of lymph nodes, and connective tissue with fat. This is the group of mesentery that attaches the small intestine. So this yellowish attachment of mesentery that is seen around the coil. See here, this is a coil of small intestine, and these are the fat layers that coils that attach the small intestine. So the fan-shaped two-layered peritoneum attaching coils of jejunum and ileum to the posterior abdominal wall and to the root of mesentery. So this is the root of mesentery where the mesentery is not only attaching the small intestine here but also attaches the colon. Okay, it's also attaching the colon. And see the blood vessels that are seen within the mesentery. So there is blood vessels that are seen within the mesentery and it is fully filled with fat. Along with the blood vessels, the presence of arteries and veins, there are also presence of the autonomic nerves that are present in the mesentery. So coming to the appendix, there is also a small piece of mesentery that connects with the appendix, what we call it as the mesoappendix. The mesoappendix becomes very important because it contains the artery called as the appendicular artery, which is the artery that supplies the appendix. And the appendicular artery always attaches itself with the mesocolon. So this is the colon and this is the appendix, this is the mesocolon. So this is the mesentery getting attached with the cecal area and the appendicular area. So here you get the blood vessels, mainly the superior and the inferior mesenteric vessels forming branches, okay, to supply the colon, large intestinal area. So the transverse colon, the root of the transverse mesocolon See, this is the root of the transverse mesocolon. It crosses the right kidney, descending part of the duodenum, and the head of the pancreas, left kidney. So the root of the transverse mesocolon crosses the right kidney, the descending part of the duodenum, head of the pancreas, and the left kidney. So this becomes important where the root of the mesentery crosses itself. The sigmoid colon. The sigmoid colon is an S-shaped colon which is seen in the hind part, and the sigmoid colon is also covered by the layers of the mesentery here. So these are the colon, the positions of the colon by the means of the varied meal they have taken a radiograph to show the foldings of the large intestine. So these are the mesenteric recesses and the posterior relations of the mesentery. So once the mesentery is completely removed, what are all the structures which are seen behind the root of mesentery? You can find the IVC, you can find the retroperitoneal organs like the pancreas, you can find the spleen, you can find both the kidneys, right and left kidneys, and you can find the abdominal aorta bifurcating itself into the both the common iliac vessels, formation of the iliac veins are present, and the body of the vertebra. So this becomes a posterior relation to the peritoneal sac. Behind the peritoneal sac, what we get is these structures, retroperitoneally. Otherwise, we call it retroperitoneally. Retroperitoneally, we get the pancreas, the spleen, the presence of IVC, abdominal aorta, presence of the both the kidneys, the right and the left kidneys, pancreas, etc. So the reflection of the parietal peritoneum is raised by the underlying vessels and ducts, the obliterated fetal blood vessels. In fetal, in the we also get the median umbilical fold, which is called the allantoid duct. So that also to be a structure which is a remnant of the umbilical vein. Okay. The median umbilical folds, the lateral umbilical folds becomes the inferior epigastric artery. So these are the remnants from which they form. The gastropancreatic fold. The gastropancreatic fold is a fold between the stomach and the pancreas. So when we reflect the stomach, we can see the pancreas. But it's connected by the means of a ligament called gastropancreatic fold, which connects the stomach with the pancreas. So this is a spleen that is located posteriorly. So the stomach is getting connected with spleen as well as it is connecting with the pancreas. If it connects with spleen, it's called gastrosplenic. If it is connecting with pancreas, it's called as the gastropancreatic fold. So along with this, we have seen different ligaments. So first we saw what was peritoneum. What are the different forms of peritoneum that was forming the omentums, the lesser omentum, the greater omentum. We saw the different sacs that was formed, the greater sac and the lesser sac. Then we saw the formation of the compartments. Then we saw the formation of the mesenteries. We saw the attachments of the organs within the peritoneum by the means of different ligaments. And now finally we will see about the pouches that are formed within the organs of the peritoneum. So within the peritoneum you get the rectouterine pouch. Pouch means it is a space that is seen covered by the peritoneum, but it is the space between two organs. For example, rectouterine. See, in a female, this is the cross section of a female pelvis. If you see, this is the urinary bladder, this is the uterus, and this is the rectum. The space between the rectum and the uterus is called as the rectouterine pouch, and this pouch is called as a pouch of Douglas, and it becomes very important for clinical investigations. This pouch which is seen in front of the uterus is called as the vesicouterine pouch. Vesicouterine means a space between the urinary bladder and the uterus is called as the vesicouterine pouch. Rectovesicular pouch is a pouch which is seen between the urinary bladder and the rectum. Because in male there is no uterus, only the urinary bladder and the rectum is present. The space between the rectum and the urinary bladder is called as a rectovesicular pouch. So these are pouches which are seen within the peritoneum. So any doubts you have, you can always ask me. Thank you for being attentive in the class, and thank you all. I hope you're all safe. Keep safe, stay home.